Pick something red in the room you're in right now. A wall, a mug, a piece of clothing, anything. Look at it. Here's a question nobody can actually answer. Are you and I seeing the same thing? Not whether we'd both call it red, we've both been taught the word. The question is whether the experience happening inside your head when you look at that object is anything like the experience happening inside mine. Whether the actual felt quality of it, the redness of red, matches what I see when I look at the same thing. No scientific test can answer this, not one. No brain scan, no wavelength measurement, no experiment ever designed can directly compare the subjective experience of one mind to another. And the more carefully you sit with why that is, the more uncertain the ground under what you call the real world starts to feel. The part everyone agrees on: light exists. Electromagnetic radiation at specific wavelengths hits the photoreceptors in your eye. Those receptors fire electrical signals toward your brain, and your brain produces the experience of color. That part, the physics and biology, is measurable, verifiable, and not in dispute. What has been argued about, in philosophy and now in neuroscience for centuries, is what happens next, that final step where the electrical signal becomes an experience, where the numbers become a feeling, where wavelength 700 nanometers becomes whatever red actually feels like from the inside. That gap is where color might not be what you've always assumed it is. Color doesn't exist outside your head. This sounds radical, but it's accepted without controversy by every neuroscientist and physicist alive. The physical world outside your head contains no color whatsoever. What's out there are electromagnetic waves at different frequencies. That's it. A wavelength of 700 nanometers is no more inherently red than the number 700 is inherently warm or cold. Color is something your brain adds, a labeling system that assigns different subjective experiences to different wavelengths so you can distinguish them quickly and navigate the world. It works extraordinarily well as a practical tool, but the tool is inside your head. When you see red, you're not perceiving a property that exists in the object. You're perceiving your brain's own interpretation of an incoming frequency of light. The apple doesn't have redness. It has a surface that reflects a particular wavelength. Your brain decided to call that wavelength red, and somewhere in that decision, made entirely inside your skull, is where the experience we're actually talking about lives. Mary's room. Philosophers have a word for the felt, private, interior quality of an experience: a quale. The redness of red is a quale. The specific sharpness of pain is a quale. The particular character of what coffee smells like is a quale. The Australian philosopher Frank Jackson made the problem concrete in 1982 with a thought experiment called Mary's Room. Mary is a neuroscientist who has spent her entire life in a black and white room. Through books and monochrome monitors, she has learned every single physical fact about color vision, every wavelength, every photoreceptor, every neural pathway involved. She knows everything science can tell you about color. Then one day, she walks out and sees something red for the first time. Does she learn something new? Jackson's original argument was yes, she learns what red looks like from the inside, and that thing she learns can't be reduced to any of the physical facts she already knew. She understood all the machinery. She had never experienced what the machinery produces. The debate about whether Jackson was right has run for over 40 years. Philosophers still disagree. Neuroscientists still disagree. And the disagreement isn't a minor technical point. If Mary does learn something new when she walks out of that room, it suggests that a complete physical description of a brain can leave out something real, that there is something it is like to see red that no measurement can reach.
Here's the version that's genuinely hard to shake because it's impossible to disprove. Imagine that when you look at something red, you have the experience I would call green, and vice versa. Your entire visual experience of color is inverted relative to mine. Would anyone ever know? You learn to call one experience red and another, green, in exactly the same situations I did. Red traffic lights, green leaves, red fire trucks. You've always used the words correctly. Your behavior is indistinguishable from mine on the outside. John Locke raised essentially the same question in 1689, and it's never been resolved. Language and behavior are the only tools we have for comparing experiences between minds. And in the inverted spectrum case, both tools give identical outputs regardless of whether the underlying experiences match. You cannot get outside your own experience to check. You've been seeing the world through your brain's particular version of the color code since birth, with no access to anyone else's version and no external measurement that could bridge that gap. The hardware shapes the experience. Most everyday thinking assumes that normal human vision captures something close to the full picture of color. It doesn't. It captures a thin slice of what's available. Mantis shrimp have 16 types of color receptors, compared to the human eye's 3. Closer to home, roughly 12% of women carry 4 types of color receptors instead of 3, a condition called tetrachromacy. Some of these women can apparently distinguish between shades that look completely identical to everyone else. Researchers who've tried to communicate with confirmed tetrachromats about what they see differently run directly into the wall Jackson's thought experiment predicts. There's no vocabulary for an experience nobody else has had, and no way to verify from the outside whether what they're perceiving is something a standard human visual system can even receive.
Your brain is actively constructing what you see. A phenomenon called color constancy shows this well. Place the same gray card in a room lit by yellow sunlight, then in a room lit by blue skylight. The wavelengths reflecting off the card into your eye are completely different in each setting, but your brain adjusts the experience, so the card still looks gray in both cases. Your brain isn't faithfully reporting incoming wavelengths. It's solving for what it thinks the world probably looks like. So what does that leave you with? The wavelengths hitting your eye right now are real. The photoreceptors responding to them are real. The signals traveling toward your brain are real. None of that is in question. What can't be verified through any currently existing or theoretically possible measurement is what happens at the end of that process, what the experience produced in your particular brain actually feels like from the inside, whether it resembles even roughly what anyone else's brain produces when looking at the same object. You've spent your whole life talking about the same world with other people, pointing at the same things, agreeing on the same labels. None of that required your internal experiences to match. It only required that your behavior matched well enough for the shared words to be useful. Color exists, just not in the place you've always assumed. It exists in you, and there's no way to fully prove otherwise.